Mercator projection. This is a cylindrical orthomorphic projection. To understand this projection, imagine the Earth's surface is marked with parallels of latitude and meridians of longitude. Now, if you place a light bulb in the center of the sphere, the light from the bulb will cast the image of all lines on the surface, along with the land masses, onto the enclosing cylindrical paper. If this cylinder is opened and laid flat, we have a Mercator chart of the world. In reality, the projection is done by mathematical calculations for small areas at a time. The main properties of the Mercator chart are: run-line courses appear as straight lines on the chart, which allows you to draw a straight line from the departure point to the destination. The angles between the run lines and meridians are unaltered, which allows you to measure the steady course to sail to the destination. The parallels of latitude appear as straight lines parallel to the equator. Spacing between parallels increase as the latitude increases. Distances are measured on the latitude scale, which are always on the left and right-hand margins of the chart. The meridians appear as parallel straight lines at right angles to the equator. Spacing between meridians is equal. Longitudes are measured on the upper and lower margins of the chart, with west longitude increasing to the left and east longitude increasing to the right. Longitude scales should not be used for measuring distance. A great circle, unless it is a meridian or the equator, appears as a curve bending away from the equator towards the nearest pole. A straight line drawn on the chart, joining two points, does not represent the shortest distance between them, unless it is drawn along a meridian or the equator. The chart is orthomorphic, which means the shape of the land and the directional angles are preserved. Limitations of the Mercator chart are that this projection is only used for charts covering areas between 70 degrees north and 70 degrees south. Thus, the north and south polar regions cannot be prepared in this method. They are prepared on polar mnemonic charts. Great circle tracks are not straight lines on the chart. Hence, these charts cannot be used for great circle sailing. By preserving the orthomorphic property, the parallels of latitude are increasingly spaced to match the east-west increase in spacing between meridians towards the poles. This means that distortion in the areas of land masses will occur. On a chart of the world drawn on the Mercator projection, Greenland appears larger than South America, although the latter is actually nearly 9 times larger in area. Mnemonic projection. Mnemonic projection is the projection of the surface of the Earth from the center to a plane tangent to the surface. For a given point, it can be any point. This is useful for projecting less than one hemisphere at a time. A chart drawn on the mnemonic projection will have all great circles appear as straight lines. Hence, these charts are useful for great circle sailing. The mnemonic projection is useful for polar charts, as the point of tangency may be located at one of the Earth's poles. A chart drawn on the mnemonic projection will have all great circles appear as straight lines. Hence, these charts are useful for great circle sailing. The mnemonic projection is useful for polar charts, as the point of tangency may be located at one of the Earth's poles. The projection is also useful for charts having a natural scale of greater than 1 to 50,000, such as harbor plans. The limitation of this projection is that it is not orthomorphic. and hence it is hard to measure direction and distance. Meridians of longitudes appear as straight lines, converging at the nearest pole. Rhumb lines appear as curves. Parallels of latitude appear as curves. As we move away from the point of tangency, the distortion in shape and size increases.